Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty. This morning, I guess it's just the two of us. Okay, so today we're going to take a look at section 2.1, which is solving equations using properties of equalities. So let's go ahead and get started. Again, section 2.1. If we have a statement like the following, today is Tuesday. In this case, today and Tuesday are equal. So we could say today equals Tuesday. We don't usually talk that way, but in fact, today and Tuesday are the same thing as of right now. If we have a statement x equals 7, this is also an equation. It tells us that x, which is a variable, takes on this specific value 7. X equals 7 is an equation. Suppose, however, we have something like this. X plus 4 equals 12. Well, now x is not by itself, so it may not be obvious what x is. X plus 4 equals 12. But if we could get one side of the equation to just be x, like it was in this scenario, then we would know what x was equal to. But we've got x plus 4 equals 12. So what we need to do is we need to subtract 4 from the left side of the equation so that the 4 and the minus 4 will cancel and we'll have x by itself. However, because it's an equation, whatever we do to one side of the equal sign, we must also do to the other side of the equal sign. So subtracting 4 from the left, we have to subtract 4 from the right. 12 minus 4 is 8. So for this particular equation, x equals 8. To check our work, we can take the original equation, replace x with our proposed solution to see if the statement we get is true. 8 plus 4, 12 equals 12. This is true. So in fact, our solution is correct. Any questions about that problem? Okay, let's say we have this situation. Y minus 2 equals 47. Again, we want to figure out what y is equal to. If we could get y all by itself on one side of the equation, then we would know y was equal to whatever was on the other side of the equation. But I have y minus 2. So to get y by itself, I'm going to add 2 to the left side of the equation. The minus 2 and the plus 2 will cancel each other out, and we'll have y equals. But because I added 2 to the left side of the equation, I must also add 2 to the right side of the equation. 47 plus 2 is 49. So we get y equals 49 as the solution to the equation. To check our work, we'll take the original equation and we'll put our proposed solution in place of the variable. 49 minus 2 is 47. 47 equals 47, that's true. So y equals 49 is a correct solution. So what we see here is that in this case, we added the same quantity to both sides of the equation. In this case, we subtracted the same quantity from both sides of the equation. Here, adding the same quantity to both sides of the equation is called the addition property of equality. The addition property of equality. It basically says you can add the same quantity to both sides of the equation, and the new equation is equivalent to the original equation. Here, we subtracted the same quantity from both sides. This is an example of the subtraction property of equality. I don't know about the loose leaf textbook, but these two properties are listed in the hard copy of the textbook on page, let's see, what is it? Page 103 and 105. Anyway, for further reference. Okay, so let's take a look at some examples. Let's see here. We've got x minus 34 equals 19. It says use a property of equality to solve each equation, then check the result. So x minus 34 equals 19. So to get rid of the minus 34, I'm going to add 34, but I have to do the same thing to both sides of the equation. So on the left, x minus 34 plus 34, those cancel out. I get x equals, well, let's see, this would be what? 1353. Let's check our work. X minus 34 equals 19. If x is 53, 53 minus 34 equals 19. Let's see. 53 minus, oops, let's get those lined up a little bit better than that. So we're going to borrow, carry. 13 minus 4 is 9. 4 minus 3 is 1. So we get 19 equals 19. Our solution checks. Okay. Let's see here. How about this one? This says -3 plus a equals 0. So I have a -3 plus a, so I'm going to add 3 to both sides. -3 plus a positive 3 is 0. 0 plus a is a. 0 plus 3 is 3. So a equals 3 is the proposed solution. And now we'll plug it into the original equation. -3 plus 3 equals 0. 0 equals 0. It checks. So that is the correct solution. Any questions so far? All right, I'll take that as a no. Let's see here. How about this one? X plus 1/14 equals 9/7. So to solve this equation, we're going to have to subtract 1/14 from both sides of the equation. X plus 1/14 minus 1/14, those would cancel out. We get x equals, I've got 9/7 minus 1/14. But in order to subtract the two fractions on the right side of the equation, I need to get a common denominator. In fact, I want the least common denominator. The least common denominator of 7 and 14 is 14. Do you have any questions about where I got that? No? Okay. I need to take 9/7 and change it to something over 14. If I multiply the denominator by 2, I get a 14 in the denominator. So I must also multiply the numerator by 2. The new numerator becomes 18. So 9/7 can be built up to an equivalent fraction, 18/14. That's interesting. Where did that come from? Okay, let's see if I can get rid of that. Yeah. Anyway, 18/14 minus 1/14 would be 17/14. Okay, so checking our work. X plus 1/14 equals 9/7. 17/14 plus 1/14 equals 9/7. 18/14 equals 9/7. I can reduce 18/14, take a 2 out of the top and a 2 out of the bottom. 9/7 equals 9/7, that is divide. Okay, it checks, so that's the correct answer. Now, we could also say that x was 1 3/14. That is not incorrect. It is a correct answer, but in algebra, we tend to use improper fractions and fractions and sometimes decimals, but not so much mixed numbers. Also, we'll find that in WebAssign, mixed numbers don't work very well. WebAssign doesn't tend to recognize them. So if this was a WebAssign question, you would have this answer, not that one, even though they are equivalent. Any questions about that? Okay, let's see here. Let's do one with decimals. 9.4 plus h equals 8.1. So to get h by itself, I'm going to subtract 9.4 from both sides of the equation. On the left side, the 9.4 minus 9.4 is 0. H equals, on the right side, 8.1 minus 9.4. All right, now, if you use your calculator, which you certainly could do, let's see what we get here. If I go 8.1 minus 9.4 equals, I get negative 1.3. Doing it without the calculator, we go through this process. Subtracting a number is like adding its opposite. Adding two numbers with different signs, you subtract the smaller absolute value from the larger. Let's see, the absolute value of 8.1 is 8.1. The absolute value of negative 9.4 is 9.4. So we subtract the smaller absolute value from the larger. We'd get 1.3, but then we attach the sign of the number with the largest absolute value, which was negative. And I know that's a tedious, lengthy process, but either way, you should get h equals negative 1.3. Any questions on that? All right, so we've looked at the addition property of equality and the subtraction property of equality. What I want to do now is look at some equations that are a little bit more complicated than that. 5t minus 4 equals negative 16. And they give us a proposed solution. They say, see if negative 2 is a solution to this equation. So that means negative 2 goes in the place of the variable. So 5 times negative 2 minus 4 equals negative 16. Negative 10 minus 4 equals negative 16. Negative 14 equals negative 16. That is not true. So no, negative 2 is not a solution of that equation. So this is just sort of a checking your work. Okay, let's see. Let's take a look at this one. It says 1.2 plus x equals 4.7. And their proposed solution is 3.5. So we'll put 3.5 in the place of the variable x and see if we get a true statement. Let's see. 1.2 plus 3.5 would be 4.7. 4.7 equals 4.7. So true or yes, this solution is correct. All right, now, suppose we have, let's see here, the following equation. 3x equals 12. There's just a single term on the left side of the equation, 3x. So we're not going to add or subtract anything at this point, but we need to get x by itself. Since x is being multiplied by 3, we need to divide it by 3. That is 3x. Dividing by 3, the 3 is reduced down to 1 over 1 or 1x or just plain old x. However, since I divided the left side of the equation by 3, I must also do the same thing to the right side of the equation. So x equals 4. Let's check our work. If 3x equals 12, and we put 4 in the place of x, we get 12 equals 12. So the solution is correct. This is called the division property of equality. You can divide both sides of an equation by the same non-zero number. So there's a restriction there. We can't divide both sides by 0. Recall from yesterday that dividing by 0 is undefined. But as long as we're not dividing by 0, we can divide both sides of an equation by any other real number than 0. So dividing the left by 3, we get x. Dividing the right by 3, we get 4. Let's take a look at another example of that. Let's say I've got negative 6x equals 18. So to isolate the variable, to get x by itself, since it's being multiplied by negative 6, I will divide by negative 6. But again, whatever I do to one side of the equal sign, I must do the same thing to the other side of the equal sign. Negative 6 divided by negative 6 reduces down to 1 over 1. 1 over 1 is 1. 1 times x is just x. 18 divided by negative 6 would be negative 3. Checking our work. If we put negative 3 in the place of x, negative times negative is positive, so x equals negative 3. Okay. Now, in WebAssign, if there's an answer that is just x, you don't want to put a 1 coefficient in front of it. Even though it's correct, WebAssign doesn't recognize that. So x, even though it's equivalent to 1x to the 1 power all over 1, we just want to write x. Okay. So let's see here. Let's do a different example. Let's say we have this. N divided by 9 equals negative 2. So we don't have n, we have what? 1/9 of n. Well, to get n, we would have to multiply both sides of the equation by that 9, which is the denominator. On the left side, the 9's reduced down to 1 over 1, and I have 1 times n, or just n. On the right side, negative 2 times 9 is negative 18. Checking our work. If we put negative 18 in the place of n, we get, let's see, negative 18 divided by 9 is negative 2. Negative 2 equals negative 2. The solution checks. So n equals negative 18 is correct. This is an example of the multiplication. Oops. Multiplication property of equality. Now, we can multiply both sides of an equation by the same non-zero number again, because if you multiplied both sides by 0, you'd get 0 equals 0, which is true, but it doesn't help solve the equation. So the addition property of equation says we can add the same quantity to both sides of the equal sign. The subtraction property of equality says we can subtract the same quantity from both sides of the equal sign. Multiplication property, we can multiply both sides by the same non-zero number. Division property, we can divide both sides by the same non-zero number. So we've got to be careful of that restriction involving 0. Okay, let's take a look at some more examples. Here we have 11/15 y equals 22. So I have a number, a coefficient in front of the variable that's not a 1 or an implied one. So I need to get rid of that 11/15. The question is, do I multiply or do I divide? Well, I could multiply both sides by 15, but then I'd still have 11y, and then I'd have to divide both sides by 11. So I can do this all at once. When the coefficient of the variable, the number telling how much of the variable you have, in this case 11/15, when it's a fraction, if we multiply both sides of the equation by the reciprocal of that fraction, a number and its reciprocal multiplied together becomes 1. So we get 1 times y, or just y. So we can get rid of that fraction all in one step. On the right side of the equation, 22, like 22 over 1 times 15 over 11. Recall that we can reduce this down to 2 over 1. 2 times 15 is 30. 30 over 1 is just 30. So y equals 30. Any questions about that problem? Let's check our work. 11/15 y equals 22. I'm going to put 30 in the place of y. 30 over 15 reduces to 2 over 1. 11 times 2 is 22. 22 equals 22. It checks. The solution is true or correct. How about this one? Negative 4a over 5 equals 11/15. Well, here the coefficient of a is negative 4/5. The reciprocal of that would be negative 5/4. Negative 5/4. On the left side, negative 5/4 times negative 4/5 reduces down to 1. 1 times 1 is 1, and 1 times a is a. On the right side of the equation, negative 5 over 15 is negative 1 over 3. So then I get what? Negative 11 over 12 as my proposed solution. Let's check our work. We've got negative 4/5 a equals 11/15. Negative 4/5 times negative 11/12 equals 11/15. Negative times negative is going to be positive, right? 4 over 12 is 1 over 3. 1 times 11 is 11. 5 times 3 is 15. 11 over 15 equals 11 over 15. So the solution is correct. Again, any questions there? All right. How about this one? Negative 1.26 equals negative 2.1 x. Well, so to get x by itself, I'm going to divide both sides by the coefficient of x, which is negative 2.1. On the right side of the equation, negative 2.1 divided by negative 2.1 reduces down to 1 over 1, or just 1. 1 times x is x. On the left side of the equation, negative divided by negative is going to be what? Positive, right? So I've got 1.26 divided by 2.1. Well, let's see. I could go to the calculator. 1.26 divided by 2.1. And I come up with 0.6. Or I could use long division. 1.26 divided by 2.1. Recall the dividend, the number on top goes inside. The divisor, the number on the bottom, goes outside. But when you're using long division with decimals, you want a whole number outside. So you'd move the decimal point 1 place on the outside, consequently 1 place on the inside. So then you would get that. You move that decimal point straight up to the answer. 21 does not go into 12. 21 goes into 126 6 times. Exactly. So our answer is 0.6 or 0.6. Okay. Let's see here. How about this one? 40 equals 5t. So to solve for t, we'd have to divide both sides by 5. So t equals 8. 40 equals 5 times t, 5 times 8. 40 equals 40. It checks. This is correct. How about this problem? 40 equals 5 plus t. Now the 5 is being added to the t, not multiplied. So we can't divide it out. We have to subtract it out. So different equations, different approaches, different solutions. So be careful of that. If the number is being multiplied by the variable, we tend to divide. If it's being added, we tend to subtract. Okay. How about this one? 1/6 equals h plus 4/3. To solve for h, we'll subtract 4/3 from both sides of the equation. So I've got 1/6 minus 4/3 equals h. Okay. To subtract two fractions, I need a common denominator. In this case, it is 6. 1/6. If it ain't broke, don't fix it. 1/6 stays as 1/6. 4/3. I'd multiply the denominator by 2 to get a 6 in the new denominator. So I'd multiply the numerator by 2 to get an 8 in the new numerator. 1/6 minus 8/6 is -7/6. So h equals -7/6. Let's check our work. 1/6 equals -7/6 plus 4/3. 1/6 equals -7/6 plus, what do we got? 8/6. 1/6 equals 1/6. So it checks. All righty. What about this one? 16 equals 16h. We would divide both sides by 16, and h equals, careful, that isn't 0. It reduces down or simplifies down to a 1, because 16 equals 16 times 1. Let's see here. How about this one? -14/3 c equals 7. So the coefficient of c is a fraction, so we'll multiply both sides by the reciprocal, which would be -3/14. -3/14 times -14/3 all reduces down to 1. 1 times c is c. 7 times -3/14, 7/14 is 1/2, so we get -3/2. Okay. Let's see. Let's check our work on that one. -14/3 c equals 7. -14/3 times -3/2 equals 7. -3/3 is -1/1. -14/2 is -7/1. -7 times -1 is +7. 7 equals 7. It checks. The solution is correct. Okay. Well, that's all I've got for today. So again, we've got the addition, the subtraction, the multiplication and division properties of equality. When you're using the multiplication and division properties, you can't multiply both sides by 0. You can't divide both sides by 0. All right. Well, I'm going to go ahead and stop the recording.